Good afternoon. Let's take a look at volume of revolution around the x-axis. The following is an exam style question, so let's take a look what they've given us. So let me activate my pen. So here we check. Consider the part of the curve 4x squared plus y squared is equal to 4 shown in the diagram below. So we can see that this here is the curve. Now, very interesting. This curve only expands from 0 to 1 on the x-axis. Since this is volume of revolution around the x-axis, this part here is very important. Now, let's first read what they're saying. For part A, they say, find an expression for dy dx in terms of x and y. So they are asking us to differentiate the curve. So let's take a look at it. They gave us 4x squared plus y squared is equal to 4. 4x squared plus y squared is equal to 4. Now, if I want to differentiate this, I notice that I've got an x and a y both here on the left hand side. Therefore, I will have to use implicit differentiation. So differentiating my first term here, 4x squared in terms of x, will give me 8x. Now, the moment I want to differentiate y in terms of x, remember I have to differentiate y, so y squared becomes 2y, but I have to multiply it with dy dx. And the moment I am differentiating a constant, it becomes 0. So we have 8x plus 2y multiplied with dy dx is equal to 0. Of course, we want to try to make dy dx the derivative the subject. So therefore, let's take this 8x over to the opposite side. So dy dx is equal to negative 8x divided by 2y. And now negative 8x divided by 2y can be simplified as negative 4 multiplied with x over y. So here I have my gradient function for the curve dy dx. So we have an expression for dy dx in terms of x and y. X and y is here on the right hand side. This was for part A. Now, for part B, luckily for us, if we read carefully, they say find the gradient. They do not ask us to find the equation. They only ask us to find the gradient of the tangent at the given point. So I know that my gradient of my function dy dx is equal to negative 4x over y if I want to write it like this, or alternatively, I prefer to write it like this for the moment. You will see why. Now, they tell us at the point, and the point given is 2 over root 5 for my x coordinate, 2 over root 5 for my y coordinate. Now, very interesting, if I want to find the gradient of my tangent at this given point, I notice that it is negative 4, and then in brackets my x value, 2 over root 5, divided by my y value, 2 over root 5, which gives me 1. So my gradient of my tangent is negative 4. And this is the answer for part B. Now let's focus on part C here, because this is why we are here today for the volume of revolution. Now they say, a ball is formed by rotating this curve through 2 pi radians about the x-axis. So it means we want to rotate this curve around the x-axis 360 degrees or 2 pi. Calculate the volume of the ball. Now, the moment I go for volume of revolution, you might have seen this formula before. The volume of revolution is equal to the integral of pi multiplied with y squared dx. Now, of course, we will have an upper and a lower bound for my function. In our case, we're very lucky because the upper and lower bound can be seen here from the graph. My lower bound for x will be 0, and my upper bound for x will be 1 as given. So therefore, I can have my integral lower bound 1, lower bound 0, upper bound 1. Pi is a constant, therefore I can multiply pi on the outside. Now, in order for us to get y squared, let's take a look here at our given equation. 4x squared plus y squared is equal to 4. Therefore, if we isolate y squared, if we make y squared the subject, then I will find, or I can substitute it straight into my formula here. So instead of y squared, we know that the following. So 4x squared plus y squared is equal to 4. Therefore, y squared is equal to 4 minus 4x squared. And this here, I can substitute into y squared for this equation. Now let's go and do it. So I'm just going to make an arrow here to continue. So this is equal to pi. I have my integral from 0 to 1, and in brackets 4 minus 4x squared, and I'm going to integrate this in terms of dx. This is equal to, and I still keep my pi outside, square brackets. Now if I want to integrate this, I will get 4x minus 4 over 3x cubed, close my square bracket, and I have 1 and 0 for my bounds. Now let's go and substitute in first the 1. Then I'm going to get pi, and I'm going to get, in all the places where I have an x, I will just substitute in a 1. And of course minus, if I were to think about the 0 here, but it will still just be 0, so we're not going to bother about that. Actually, this should have been in a larger bracket. That's fine. And now if I were to simplify this, I would get pi in brackets 4 minus 4 over 3. And now if I simplify this, I will get 8 pi over 3. Now this is the volume of revolution of my curve around the x-axis.